Well, hello guys, welcome back to John's Workshop, and in this video we're going to finally make a start on the upgrades that I want to make to my Cormac milling machine. So back in the past did some work to this machine when it first arrived. I've run it for 18 months, probably getting on 2 years. Have found out its weaknesses and want to address as many of those as I can to make it as good as it can be for a home shop mill. So just going to talk very quickly through the plans in case this is the first time you've come across this video. I've mentioned them before for my regular viewers, so I'm going to spin through quick. I'm going to exchange the Morse taper 4 spindle for an International 30 taper spindle. That's one mod. I'm going to fit a clamping ring to the bottom of the spindle to stiffen up the spindle and maybe alter the clamping the way we lock the spindle. Don't know on that bit yet, we'll see as we get into that bit. Change from my static 3-phase converter that gives me electrical noise through the head, through the gearbox and into the spindle, which causes vibration and chatter and lots of other issues. So we're going to replace that with a VFD and possibly a motor swap out as well, again yet to be defined. And also probably going to go for a change of head drive system to go from a geared head mill, so ripping all the gears out and going for a straight belt drive between motor and spindle. Again, yet to be thought out, yet to be defined. This is going to run as a series of videos over the course of the next few months really, and I need to pick my timing carefully so that I don't leave my mill unoperational for long lengths of time while I'm doing this, so need to fit this in at the right times. And so yeah, this video is starting off, so I've got a International 30 spindle which is second hand, although brand new, never been used in a machine. So in this video we're going to get stuck into that. We're going to give it a thorough clean up, a strip down and an assessment of whether we need to do anything bearing wise or anything like that, and a thorough measure up so that I can then work out my next plans in terms of making the locking ring at the bottom, the steady ring, and various other bits and pieces as well to check what this kind of fit's going to be inside my mill, because I don't think these come matched, but they're just all thrown together in the factory, so it should be no worse than the one that's in the mill, but need to check that out dimensionally. So a few checks to do, some tear down, some assessment, and that will be the start of this mill series, which is going to run on for a good long while I think. So without any further babbling, just checking the board. Yep, I think we've done everything, so let's get started. I'll bring you in shortly, we'll get the new spindle up on the bench and we'll start the cleanup process. Okay, so this is the NT30 spindle. It's second hand, although it's never been run in a machine, so effectively it's brand new. It's been at the back of somebody's workshop for some time. We've got some corrosion on it, we've got some muck. If we look in the back where the rear bearing is, we've got plenty of swarf that's got stuck into the grease in there, and I would imagine the front bearing might have some in as well that's gone in through the Morse taper slot. So the first job really with this is to get this cleaned down. I'm using my temporary bench because my proper bench has got shaper all over it, and you know, I'm in the middle of a shaper refurb as well, so we're going to do the work on this bench for now. So I'll join you in a minute as we'll take the drawbar out. That's the first thing we can do. So this is an M12 drawbar. Not sure if we're going to keep this or whether we're going to make something different. Don't know yet. Probably going to make something better than that. We're going to set about this, get it cleaned up for a start, get rid of the surface rust. So I'll show you a bit of that, and then once we've got to a point where it's clean, we'll then start to think about what we do next in terms of strip down. So I'll bring you back in a minute. So we're ready to go. We've got some clean Scotch-Brite, some WD-40 and a various selection of tools for cleaning the grooves out in here in the rack. So without any more babbling, we're just going to get right on into it and see how well this surface rust is going to come off with a bit of Scotch-Brite. I don't think it's too bad. Yeah, already seeing some score marks in the OD. They'll not cause a problem, but they're slightly raised, so a bit of fine oil stone work required. There's 2 grooves there, not too bad. So that's what I'm going to carry on doing. You don't need to watch me do any more of that. I'm just going to get the worst off and get it into a state where we've removed the corrosion, we've got it cleaned up best we can in terms of what we can see, and then we'll start the tear down. So I'll bring you back when we're at that point and we've got it looking, you know, as good as it can all over. So my spindle's now got measles. Following some initial cleanup, we've done a rudimentary inspection of the surface, which is really a bearing surface that rides inside the casting, inside the spindle, and all of these areas, as you can see here, are damage areas that are on the outside surface of the spindle, and they're in various areas, and this is just basically, I think, handling damage, storage damage, that kind of thing. Now none of them are particularly bad, and I seem to be rubbing them all off with my fingers because I didn't get rid of the WD-40, but there's a line of them down here that are deeper than the rest, and I think they're all solvable. But what I'm going to do first is I'm going to take some measurements off the diameter of this all the way down, and then I'm going to compare that to the spindle that's in my mill, because I think this outside spindle cartridge is the same as the one that's in my mill, which is pretty much brand new and should be unmarked. If they are the same, I've already assessed the fact that I've got to strip this spindle down to get to either clean the bearings out or replace them with new bearings to make sure there's no swarf in them. So at that stage I've got then the option of rebuilding this spindle, but not with this outer cartridge, with the outer cartridge that's currently in my mill. But I want to do some checks on the diameter here versus the spindle that's in my mill currently, and just see what kind of difference there is. And I really want to be putting the biggest one in the mill, because mine's a bit sloppy already. So if this is bigger diameter slightly, then this is the right one to go back in, but with the cleanup done on all these damage areas. So I'm just going to do some measurements now. So the results of that measurement, the spindle cartridge that's in my mill is 30 microns bigger diameter than this spindle cartridge. So if I put this one, you know, if I fix these apologies on the outside surface and use this one, I introduce 30 microns more slop than I've already got on my existing cartridge. So what I'm going to do is strip both spindles down, and I'm going to insert the central portion of this spindle into my spindle, and hopefully that's all going to work. I'm hoping that the internals in here are the same as mine, and it's just the very spindle, the centre spindle, that's the difference between Morse Taper 4 and INT 30. So next job really now is to strip this spindle down, get the central portion out. So we'll do that next. Okay, the plot thickens. So we have completed this bit, the actual spindle piece itself. So we've extracted the bearing from this end, and we've cleaned up all of the corrosion. There was quite a bit of corrosion on this. There's a tiny bit of pitting left behind on this bottom piece that doesn't really matter. too much. The bore itself, because it's never been used, the taper is absolutely mint. And so yeah, we've also been round these edges that are absolutely razor sharp, and we've put a bit of a brake edge on. I was expecting this to be hard. It's not. I think they've probably used something like pre-hardened 4140, something like that, for this. So this hasn't been through another hardening treatment, I don't think. So I was able to do all that brake edging around there with a file. It was tough, but it's cut it okay. As I say, we've taken all of the corrosion off the splines. There's a couple of bits of damage here and there, just minor, so we've taken all of that off. So that bit is now largely ready for reassembly, other than I want to flush right down the bore, which I'll do just prior to reassembly. So what do we mean by the plot thickens? Well, once I got the bearing off the shaft, which was this one, I then had to get the cup out of the end of the cartridge, which is this one, and on extracting that and measuring it, it became evident straight away that this is a different size bearing in the International 30 spindle than it is in the Morse Taper 4 spindle. So I cannot now use my cartridge at my mill, so I've got to use this one that's 20 or 30 microns down on the OD diameter of this, and it also means all those areas of damage I now need to dress and sort out. So, but before we do that, the next job is I need to get the opposite end cup at the other end of the spindle. So that's what we're going to do next. Hopefully I can get my puller in here to get that out, so I'll just get that set up, probably show that on camera. So back in a moment. So we've got our puller engaged, just using a bit of old lathe tool shank, and I'm actually using the dogs at the end of the spindle, which aren't going to get used as dogs, as spacers. I might need some thicker spacers in a minute, but we'll use those to start with, just to get this moving, hopefully. So let's see what happens. Let's have a go with this bit of tube. A little bit agricultural, but no harm done, and cup removed. So the next job now is to clean all that gunge out of there. When I took this one out, I actually had a bit of a concern to start with. I found some eggs in there. Well, what I thought were eggs, and I thought, surely no. I've not heard of any beetle, insect or anything else that actually lays its eggs in grease in the middle of a spindle, by the way. And I was gingerly moving around it, trying to remove the grease with my grease removal tool, wondering what on earth these eggs were. And it turns out it was some little balls of polystyrene that had obviously found their way in through the Morse taper slot and to the back of the bearing and got all caught up in the grease, which is a really good reminder of just how vulnerable this slot actually is in these spindles. massively vulnerable, and this is going to be getting blocked off. So I'm going to give this a good clean up now. You don't need to watch me do that. An egg. Okay, so we've finished our work on this spindle now, on this spindle cartridge. We've gone round and addressed all of the dings, scratches, apologies on the outer diameter. You've just seen me with a Dremel stuck down one end and a shop vac stuck up the other, and that was a day or so ago. And what that's all about is, and I would strongly advise anybody who's got one of these mills, regardless of the make, if you've got your machine stripped down to this level, to do what I've just done, which is, you can see down the middle, hopefully it's not, the light's not the best, but that's been Dremeled out through that central bore to get rid of all the flaking steel. There's grit, there's sand, there's bits of corrosion, there's all sorts in there, and that's now been sealed up with some Smooth-Right Blue. It's just what I had kicking around. That surface is now sealed, so it's not going to corrode anymore, it's not going to flake off bits of stuff, there's not going to be bits of sand coming off it dropping down into the back of this taper roller bearing at the front end. Those bores are absolutely shocking on all of these mills. So this is the third one of these I've had in bits now, and all three of them have been exactly the same, and they've all come through different. This one came, I don't know where this one came from, one of them's come through Chester Mills in the UK, and the other one's come through Cormac in Poland, and they're all absolutely identical. So yeah, if you've got your mill stripped down this far, that's probably one of the best things you can do to protect the life of your lower spindle bearing at the front. So we've been round, we've dressed, we've taken razor sharp edges off the corner of the threads, bits and pieces like that. We've taken all the damage off, as I said, we've tidied that up. We've been round and we've been through all of the rack, just nice and gently with a diamond needle file, just to make sure, taking any nasty horrible sharp edges off and things like that. So that's all been dressed. We've cleaned out the bearing diameters. I've not done anything abrasive in there, all I've done is just given them a wipe. They're in pretty good condition, both ends. We've deburred the keyway slot, taken all the nasty horrible sharp edges off that. So yeah, it's a good couple of hours work on this to get to this state. So what I've now done, and you'll see hopefully all of the numbers, I've been over this with my, it's brand new Moore and Wright 75 to 100 micrometer, and very carefully mapped the surface, because I'm going to be making a clamping ring and stability ring at this bottom end that this thing is going to slide through. So what I need to know is what's actually going to be sliding through it, so that when I bore the ring out I can make it to suit this to get the tightest possible fit, but as a free transition running fit on this cartridge as it comes out. So we've got between this should be 75mm nominal, and all I've done is, this is undersize, and all I've done is shown the amount undersize under nominal 75. So we're 70 microns down here, 72 down, 72, 75, 75, 75, 75 and 80 microns down. So we're between 70 and 80, so we're 10 microns taper, which is pretty good actually. I'm really pretty impressed with this. And what I've done is mapped it at 90 degrees, and I have checked it in a couple of other places as well, and I'm getting the same readings to check for any out of roundness we've got. So we were between 70 and 80 down at 90 degrees. On this side we're between 65 and 70, so we've got about 5, 6, 7 microns out of round, but as I said, between 65 and 70 there's only 5 microns taper end to end at this position. So all up, worst amount of error, if I added everything together, lowest number to highest number and the full range of the out of roundness, we're probably talking somewhere in the region of 15, 16, 17 microns over the whole thing, uncertainty based on taper and out of roundness, which is pretty good, I've got to be honest, considering where this has come from. That is pretty good going, and also the fact that I've been all over this taking out dings and marks and things. So yeah, really pleased with that. Happy with the state it's in now. It feels nice in the hand, there's no sharp edges anymore. It's had a couple of hours graft on it to get it to this stage. So the next job now is I am now going to measure up this drift slot, because this is a standard cartridge for all the spindles, and this is only required for Morse taper spindles, so completely not required on a ISO 30 spindle. I'm going to make a bit of aluminium up, a tapered wedge to go into this slot, and then we've got some JB weld that we're going to use to cover it up, and then we're going to blend that off when I'm finished. Okay, we've got the Morse taper slot filled, so I've got an aluminium plug, the shape of the slot fired in there, JB weld on top, smoothed off, polished. There's a few tiny gaps around the edges. I should have put more on really, but was just trying to be neat when I laid this in. That's really not going to matter. I'm more than happy with that. In terms of what that's doing, stopping muck getting into the spindle and into the back of the bearing, more than good enough. So I'm leaving well enough alone. I've now got my Timken bearings, so one for the bottom end, the big one, and one for the top end, the small one. So I'm going to set away and get those fitted. I've done a video on that previously when I did my old spindle, so if you want to see that, go back and check that video out. Nothing special about putting these in. These are going to go in the freezer, the shells in a freezer bag to get them down to -18. We're going to put a small bit of warmth around this, not a lot, just to get it up to 60-70 degrees, something like that, but no more than that. And then we're just going to drop these in. They might need a very slight tap with that temperature difference, but not a lot at all. So I'll get both bearing shells put in, and then we'll get the spindle loaded inside that, and I'll bring you back when I'm setting the preload. So we've got our spindle back in our cartridge, all the bearings fully greased up, fitted. We've now got a clock on the end of the spindle, and what I'm doing now is setting the preload. So if you have a look at this, you'll see we've got about 0.35 of a millimetre, there or thereabouts, repeatable, back to 0 each time, end float. So what we're going to do is gradually creep up on this now until we take that out. Now what you can't see is I've got a C-spanner on the other end tightening the nut up. Still 0.35. Down to about 0.32. We're about 0.15, just under. So what's that, about 6 thou in old money. We've now got about 0.03, 30 microns, So we're getting very close. And what I'm looking for now is where my next tab is on the tab washer. Let's take a bit more in. Right, so we're down to about 10 microns there now, and I've got a tab that lines up with the tab washer with probably not even 10 microns. I'm really struggling to influence that clock, if I'm honest, so I'm going to call that for now done. As this runs itself in and the grease disperses out of the bearings, this will slacken back off, so in a period of time I'm going to have to take this back out of the machine and just recheck this. But I'm right up on absolutely zero end float there at the minute. Now when this thing warms up it's probably going to go even tighter, but that feels very nice. It's not stiff to turn, so yeah, happy with that. Now I'm not an expert at this stuff. That's what makes sense to me to do. That may be totally wrong, so if you're doing one of these yourself, it's probably worth just checking out to see if there's any different rules around that. But to me, running with any end float at all just seems like a bad idea. Running with too much preload seems like a bad idea because you're just going to heat your bearings up. So for me that seems like the ideal solution. There's a tiny bit of movement there, but it is tiny. You're probably talking 5 or 6 microns. For running purposes I'm going to leave that, and then we'll double check that after it's been running and see what it's like. Well, there we go guys, that gets us to the end of the first video in the series on revamping the head of my milling machine. I'm really pleased with how that's gone so far. We'll see how that performs in the machine now. I'm in a good position now because I've got my existing spindle still in the mill, can still use it. I've got this spindle that's ready to go, so I could just do a swap out with these two spindles just for now and do the rest of the work, that's what I'm planning to do around the new spindle. But if I need to, I can always take it back out and pop the old spindle back in for the moment being while I'm still doing all the mods. So it's given me some options. So as I said, really pleased with that. I think that's gone really well. Nice and straightforward really, not as frightening as it may seem, so don't be frightened to have a go at it. It's not rocket science, this stuff, so it's, you know, it's fairly straightforward as long as you've got a few basic tools to be able to strip things down and rebuild them. So I hope you've enjoyed that. We'll be moving on with this, you know, the mill series now. The next job will be to make the cast iron ring that goes around the bottom of that spindle cartridge you've just seen, the locking ring and stability ring. That's going to be the next job on the list, so that'll be coming up in a future video. So with all of that being said, I hope you've enjoyed that. Thank you to the subscribers and thank you to the new subscribers that have come along, and we will catch you all very soon on another video when we'll be making something else.